Hey guys, this is Rachel Higgins, and I did my topic on chemistry behind soap. I thought this was kind of a good topic since we're in the middle of a pandemic, and we should all be using soap to wash our hands to make sure we're safe and clean so we can try to get rid of this and try to get back to a normal life. So let's get into it, you guys. So, what is soap? Soap is made by sodium or potassium fatty acid salts produced from the hydrolysis of fats in a chemical reaction called sampiofiction. I'm so sorry if I pronounced that wrong or butchered it. Just bear with me. This is a process that involves the conversion of fat, oil, or lipid into soap and alcohol by the action of heat. So, a little history for you guys. I know this is chemistry, but we all need to know the background of soap and where it came from. So, the earliest known written soap recipe is credited to the ancient Babylonians. A soap-like material found in clay cylinders. These clay cylinders was found in Babylon, a city in ancient Mesopotamia. Sorry if I pronounced that wrong. Evidence was found that soap making was known as early as 2800 BC. According to a Roman legend, soap was named after Mount Sapio, an ancient site of animal crucifixions. So after an animal was crucified or sacrificed, rain would wash animal fat and ash that collected under the ceremony altars down in the banks of the Tiber River. So after the heavy rains, women would wash their clothes in the river, as always, and then they would notice some parts of the river, if they washed their clothes in those parts after a heavy rain, they would notice that their clothes are getting cleaner. So that was technically the first use of soap because of the ash and fat from the animal. Voila, soap. Honestly, I don't even know how that would make anything clean. It's just weird, but we're going with it. So, the principle of how soap works, soap is made of molecules with two different ends. One is hydrophilic, and this end of the soap molecule loves water. The hydrophobic end does not mix with water very well, and therefore is repelled by it. Literally does not stick to it, doesn't do nothing. Just, yeah. It's like, oh, we don't care your water, so. When you mix soap and water, the soap molecules position themselves into tiny clusters. The hydrophilic part of the soap molecules points out, and the hydrophobic parts group together on the inside, which this causes the oil to be trapped inside the soap when you get it onto your hands. So you get your hands wet before you put on your soap, and then you put your soap, start washing your hands. And then when the water is washed over your hands, the hydrophilic parts are attached to the water, taking the soap and the ground connected to the soap with it. That's when you're rinsing. So like when you get the soap and water, you're washing your hands, and then when it's time to go, the hydrophilic molecule is like, okay, we're taking the dirt with us, bye. And it goes down the drain. So that's how you clean your hands with soap. How is soap made? Soap is formed by mixing fats or oils with strong bases such as sodium hydroxide. This is also called lye. This is traditional way to make lye is to leach ashes with water. The ashes contain many amounts of sodium hydroxide which dissolves in water, forming a solution of sodium hydroxide. So, does soap kill bacteria? Soap is made to decrease water surface tension and lift dirt and oils off surfaces. It can be easily rinsed away, though regular soap does not contain added bacterial chemicals. It is effective in getting rid of bacteria and other virus-causing germs. So let's talk about antibacterial soap so antibiotics, I didn't say that right. Antibacterial soaps have all the same properties as a regular soap, but it has all these extra ingredients like antibacterial chemicals added that is intended to stop bacteria remaining on your skin from replicating itself. Antibacterial soap is a cleaning product with active ingredients added and not found in regular soaps. So this chemical is made to get rid of all the bad bacterials on our hands, but FDA is actually trying to get rid of antibacterial soaps because this chemical, the antibacterial chemical that are in these soaps, are very harsh on the skin, and they are trying to get completely rid of that. So they're trying to make alternatives of antibacterial soap that is more safe for our skin, and yeah. So, of course, I wanted to put a cool fact. Like, what the heck? Is there actually cool facts about soap? There actually is. Read a couple, but I thought this one was kind of funny because I see my grandparents, like, yeah. But back in the day, people thought it was actually, like, it was bad to use soap. Like, when the American colonies began, most people avoided bathing and the use of soap. It was a common belief that water spread diseases, and a layer of dirt was good and protective. See, the reason why I said it like relates, because I swear I've heard some of my grandparents say, oh, a little dirt's not gonna kill you. It's actually gonna, like, dirt can clean you. And I'm like, what? But, like, yeah, actually, back in the day, people wouldn't use, like, when they took baths, they wouldn't use soap. They just put, like, a little bit of water on them and just was like, heck yeah, let's go. But now, if you don't use soap, you're going to smell. So, I don't, just, people need to start using soap again because we don't want to be smelling other people's odors. So, yeah, I thought that was kind of cool fact about that. But here's the end of my presentation. I hope that you've got a useful point of soap and what the chemistry of behind that was. I hope everybody knows how to wash their hands and use soap. Now you know more about soap, so hopefully when you're washing your hands, you're like, oh, cool, I got some cool information and background on soap. So, yeah. But let's wash our hands to keep everybody safe from this COVID and try to get back to normal by using soap when we wash our hands. Thanks, guys, for watching my presentation.